Danny doing the probability homework 5 problem 1, and problem 1 just wants you to show that when you find the distribution and probability density, it doesn't matter which integral you do first, because you'll get the same answer. And so to illustrate this point, you have z equals x plus y, and you can write this in terms of y equals or x equals. So when y equals, it's y equals z minus x, and you get this graph. And when you write it in terms of x, it's x equals z minus y. You get this graph. It's the same graph, but you switch the axes, and this line is x equals z minus y, and this line is y equals z minus x. So keeping that in mind, we know that capital F of z is the distribution function, and you do a double integral here, and this is just a general case. When you do it for this graph, when you write out the limits for this, if you do the integration with respect to dy first, you would do it from negative infinity to z minus x, and the outside limits for d of x would be negative infinity to infinity. But for this one, it's the same thing, except when you do the integration with respect to dx first, you write negative infinity to z minus y, and then it's when you do the second integration with respect to dy, you get your limits are from negative infinity to infinity. So when we look at small f of z, which is the probability density function, you basically take the derivative with respect to z of capital F of z, and this is just a general case. You take the derivative of the double integral. So for the for the case on the left side, you take the integral of this, and you take the derivative of this double integral, which I already wrote here, and you can simplify this to just dx in terms of, you can take one integral in terms of dx, and you use this density function from negative infinity to infinity. And for the other case, you take the derivative with respect to dz of the capital F of z, which I wrote here, and you can write this, you can simplify this to one simple integral with respect to dy. And if they're both independent, if both f of x and f of y are independent, you can rewrite this as a multiplication inside the integral. So for the left side, you would have f of x times f of y, but inside it would be z minus x, because we found that earlier that y equals z minus x. So for the other case, you would also write the multiplication of f of x and f of y, except for inside the variable inside f of x is z minus y, and you can simplify further into convolution equations. And as we know, convolution, it doesn't matter which one you take the function to be time shifted, you will get the same exact answer. And this is what problem 1 wants us to explain.